Question 11, Part B. Calculate the size of the acute angle between the lines y equals 2x plus 5 and y equals 4 minus 3x. We can use either trigonometric techniques or vector techniques to find the angle between the two lines. In this solution, I'm going to use vector techniques, and in particular using the vector dot product relationship to find the angle between the two lines. Now the angle between the two lines is identical to the angle between the lines y equals 2x and y equals negative 3x, since the angle between the lines depends on the gradients, not on the y-intercepts. So I've sketched the two lines here. We have y equals 2x, that's got a positive gradient, and y equals negative 3x with a negative gradient here. I'm going to call this line vector u and this line vector v. Now, using the vector dot product relationship, we have vector u times vector v in component form being multiplied together is equal to the magnitude of vector u times the magnitude of vector v times cos theta. And theta represents the angle, either acute or obtuse, between the two vectors. So depending on the angle theta that we obtain, if it's obtuse, we'll need to find the equivalent acute angle between those lines. Now we can see here that one of the angles will be obtuse and the other angle will be acute. So we can find either one depending on which angle we're after. Now, vector u can be expressed as 1, 2 in component form, and vector v can be expressed as 1, negative 3 in component form. And the magnitude of vector u, using Pythagoras' theorem, is the square root of 1 squared plus 2 squared, which is root 5, and the magnitude of vector v is the square root of 1 squared plus negative 3 in brackets squared, and that gives us root 10. And multiplying the left-hand side using component multiplication, we have 1 times 1 plus 2 times negative 3, which gives us negative 5. So the dot product equation becomes negative 5 is equal to the square root of 50 times cos theta. Making cos theta the subject, we get cos theta is equal to negative 5 divided by root 50. And taking the inverse cos of both sides to make theta the subject, we get theta is equal to inverse cos of negative 5 divided by root 50, which equals to 135 degrees, which is obtuse. And since we want the acute angle, we just subtract 135 degrees from 180 degrees, and we get 45 degrees. Therefore, the acute angle between the lines is 45 degrees.